Hi everyone, Vega here, and in today's feature-length video, we travel northwards to the constellation of Boötes and revisit the beautiful red giant star of Arcturus, the third brightest single star in the night sky. So let's get to it. First of all, where do we find Arcturus? Well, it's not all that easy to find, but if one can find Ursa Major, or more importantly, the Big Dipper asterism that's contained within the constellation, we then follow the tail. As we can see, it makes an arc here, and that arc eventually ends up at Arcturus, which is one of the brightest stars in the sky, so it should be fairly noticeable. Also known of course as Alpha Boötes. What kind of stellar class is the star? We see here the Sun in the middle of the main sequence, a G-class dwarf with a surface temperature of around 5700 Kelvin. So where's Arcturus? Well, Arcturus is not on the main sequence, with a luminosity much higher than the Sun, but a surface temperature much cooler, of around 4200 Kelvin. It's a K-class giant star. Does this make the star more massive than the Sun? The answer is no, not really, because it's only 1.08 solar masses, so in terms of mass it's not really that much more massive, but its radius is substantially higher at 25.4 solar radii. And indeed, I think it's fair to say that Arcturus deserves the nickname of red giant star. Next up, let's compare relative sizes. You can see here the Sun as a small yellow dot. After that, Vega, more voluminous at 2.36 solar radii and slightly more massive star, as well as you can see. If we jump ahead a few classes to Aldebaran, also known as Alpha Tauri, that particular star indeed pushes towards the supergiant category, although probably falling short at 44 solar radii. Although again we can see that Aldebaran is only 1.16 solar masses, and again, it's not actually much more massive than our Sun, and very similar of course to Arcturus, which although its radius is somewhat smaller than Aldebaran, at about half. Both are K-class giants, and both, as you can see, have very similar masses. So let's compare Arcturus to other bright objects in our night sky. First of all, Arcturus is 36.7 light years distance, which positions the star in our relative local cluster of stars, and its luminosity here is interesting at around 170 times that of our Sun. And again, remembering that the Sun and Arcturus's respective masses are very similar, so a much brighter star, but with the same amount of mass. In our skies, Arcturus, if we look at a list of the brightest objects, is the 11th brightest object, and the 4th brightest star in the night sky after Sirius, Canopus, and Alpha Centauri. So you might wonder what might happen to this list if we were to place our Sun with Arcturus. How bright would the star become as seen from Earth? The answer is extremely bright. Obviously, with its 170 solar luminosities, Arcturus's apparent magnitude jumps up, this time, to -32.55, so a much brighter star than our Sun. In this graphic we can see the beautiful city of Shanghai in China, and we imagine Arcturus developing in the sky, replacing the Sun. The beautiful Oriental Pearl Tower, and here we're able to see a plane flying across. Will it escape the rays of Arcturus? Arcturus starts to take over, and the sky turns red. Only Superman can save us now, surely. But no, Shanghai in flames, structures are destroyed, Jinmao Tower is no more, and Shanghai is obliterated by the power of the star of Arcturus replacing the Sun. Finally, the last people, can they survive? Let's face it, probably not. It seems the Earth is most likely toast from this point on. Here we see a diagram. Of course Arcturus has replaced our Sun, and we saw what happened to Shanghai, so let's move out a little bit further to Saturn's moon of Titan. The habitable zone of Arcturus lies between 12 and 23 astronomical units, so Titan may be a little bit closer at this point. Let's find out what happens. Here we can see Arcturus rising in the sky, starting to take over the Titan atmosphere. Frozen water begins to melt, thickening even further the Titan atmosphere, which is already thicker than our Earth's. The Titan sky slowly starts turning blue, with the oxygen in the clouds. Frozen lakes of ethane disappear, and Titan comes back to life. The beautiful landscape of Titan, now with the sky completely blue. The huge Arcturus about the same size as the Sun now in our skies, or maybe a little bit bigger. And there we go, Titan becoming a very wonderful place, and possibly even habitable, as long as Arcturus doesn't get any hotter of course. So let's carry on but change the parameters a little bit. Let's move Arcturus out to 13,000 astronomical units or 0.2 light years. Incidentally, this is the distance between Proxima Centauri and the Alpha Centauri AB system. And let's move ourselves back to Earth, So if we were on Earth and Arcturus was at 13,000 astronomical units, what might we see? Here we can see the beautiful city of Paris and the lovely Eiffel Tower with Montmartre in the background there. And what happens? Arcturus slowly rises in the sky, develops, and there at apparent magnitude of -12 practically, Arcturus becomes far and away the brightest star in the night sky, almost as bright as the full moon, although not quite as bright. But remember, Arcturus is 13,000 astronomical units away, almost a fifth of a light year. Arcturus dominates all the other stars in our skies. What about Arcturus in fiction? Arcturus as a famous star has been used in many things down the years, and here are some of the most famous. First of all, the slightly younger members of our channel might know that Arcturus the third in the Harry Potter series. Or perhaps those of you that are fans of the Aliens franchise might remember a conversation about Arcturian systems between the colonial marines. Vasquez, Hicks and Hudson all talked about their previous exploits in the Arcturian system. Or maybe perhaps the most famous is the Hitchhiker's Guide to the Galaxy. The Vogon Starfleet were all of course from Arcturus. Let's imagine these characters were on one of these huge Vogon spaceships going back towards the Arcturus system, and let's imagine what might happen. Here we can see Arthur Dent and Marvin the android gasping as they approach the Arcturus star. "Oh no, the xenomorph has spewed acid on the controls. We're all going to die," says Arcturus III. The spaceship gets too close to Arcturus.
The red giant star of Arcturus is very much an analogue of a future version of our own beautiful Sun. One of the oldest stars in our immediate vicinity, its red magnificence mesmerises many of us in the Northern Hemisphere. Currently in the latter stages of its stellar evolution, Arcturus is classified as a red giant star. This means it has exhausted the hydrogen fuel in its core and has expanded significantly. Red giant stars like Arcturus are typically at a stage where they are burning helium in their cores and undergoing complex processes that eventually leads to their demise. Not dead yet though, the star continues evolving, and indeed, in the coming millions of years it will transform from a red giant, shedding its outer layers of gas and dust into space to create a shell of material around the core. And yes, this expelled material may contribute to the formation of new stars and planetary systems. As many watching this video already know, the ultimate fate of Arcturus is to become a white dwarf. After it has shed its outer layers, the core that remains will collapse until electron degeneracy stops the star from further collapse under its own gravity. Basically, and very briefly, electron degeneracy occurs in incredibly dense environments, like stellar cores or white dwarfs. It arises from the Pauli exclusion principle, which forbids identical fermions, such as electrons, from sharing the same quantum space. Pressure driven by this principle counters gravitational collapse and stabilizes objects like white dwarfs. As you may imagine, it plays a crucial role in determining the final fate of stars, preventing further collapse in less massive stars like Arcturus. The easiest way to spot Arcturus is by following the curve of the handle of the Big Dipper, but frankly these days it's easier to use apps on your mobile phone that can directly point you in the direction of any star you choose. As a side note, I recently started using one myself, and apart from identifying stars like Antares or Fomalhaut, which is now possible for me living in Spain, I also seem to enjoy looking at the southern hemisphere stars like Mimosa, Alpha Centauri or ARCTURUS, albeit through my floor. Anyway, joking aside, although Sirius is visible from parts of the northern hemisphere's winter, Arcturus technically is actually the brightest star in the northern celestial hemisphere. Located relatively close at 36.7 light years from the Sun, it has a spectral type of K1.53, and indeed is an aging star of around 7.1 billion years of age. One of the more strange characteristics about Arcturus is that it is about the same mass as the Sun, but because it has expanded 25 times its size, it is now around 170 times more luminous, and it offers a glimpse at the future of our own system. As we like to discuss on this channel, however, in the past the progenitor star of Arcturus was unsurprisingly likely a G-type main sequence star, similar to the Sun, albeit with a mass perhaps in the range of 1 to 1.5 times the mass of the Sun. The exact mass may vary, but it would have been within this general range, and possibly like Alpha Centauri A or Rigel Centaurus, as Arcturus would have lost mass over the eons of time of its existence due to stellar winds. known of course as Alpha Boötes. The name of the constellation itself comes from Latin, Boötes, which translates as herdsman or ploughman. It certainly has a strange and difficult pronunciation, Boötes. Perhaps give it a try yourself. Going back to the star though, interestingly, in order of redness, Arcturus fits nicely into a table of famous stars. In something like this order of increasing redness, we see Pollux that has a BV colour index of 1, Arcturus itself with 1.23, Aldebaran at 1.54, and most red of all is Betelgeuse at 1.85. Indeed, the star is actually moving rapidly, 122 kilometers a second in fact, relative to the Sun, and is more or less now at its closest approach. Perihelion, this closest approach, is predicted in about 4,000 years from now, where the star will be a few 1/100th of a light year closer to Earth than it is today, and so indeed it ever so slightly brighter, although not enough to make any obvious difference to the naked eye. With no confirmed companions so far, Arcturus is currently alone, but many think there is certainly something big in its vicinity. Some believe there's a dim, faint star-like companion, perhaps 20 times dimmer than the parent star, whereas others have put forward the theory that there may be a substellar object, nearly 12 times the mass of Jupiter. The object is thought to be located roughly at the same distance of orbit from Arcturus as the Earth is from the Sun, at 1.1 astronomical units. Authors have, however, concluded that the variation is likely to be intrinsic to the star, rather than due to a gravitational effect of a companion. The fourth brightest star in the night sky per se. Interestingly, however, Arcturus is actually brighter individually than either of the Alpha Centauri stars from Earth. It's only the combined apparent magnitude of Alpha Centauri that makes them brighter than Arcturus. It seems that two heads are brighter than one, or at least in the case of Alpha Centauri. Finally, once Arcturus exhausts its helium supply, its outer layers will likely bleed off, leaving behind that red dwarf remnant. But the question is, how long will this take? With Arcturus' estimated mass of about 1.1 to 1.2 times that of the Sun, a rough guess says that the star likely has a remaining lifespan of a few 100 million years left, before it finally exhausts all that nuclear fuel and becomes a white dwarf. The transition from a red giant to a red dwarf itself takes quite a while though as well, as it sheds its outer layers into a planetary nebula. The process typically is thought to take tens of thousands to perhaps a few 100,000 years. In essence, while Arcturus is relatively close to the end of its life compared to younger stars like the Sun, it still has several 100 million years left before it becomes a white dwarf. In today's final graphic, we imagine if Arcturus were to suddenly approximate our solar system and appear in the sky, somewhere in the vicinity of Alpha Centauri, at around 4.3 light years distance. We see the Alpha Centauri stars shining beautifully at minus 0.27 apparent magnitudes, which is the third brightest star in the night sky. But now we see Arcturus reappearing, and astonishingly, we see the star now shining at some minus 5.2 apparent magnitudes, again at the distance of Alpha Centauri, which is substantially brighter than the planet Venus, 75% brighter in fact. At 4.34 light years, Arcturus would be a phenomenal star, although let's be honest, at its current distance of 36.7 light years, it's already fantastic enough, isn't it? Arcturus is a beautiful red giant star in our local vicinity, a future analogue of our Sun. It's the third brightest individual star in our night sky, redder than Pollux, but oranger than Betelgeuse. Arcturus will eventually fade over the next few tens to hundreds of millions of years to end its life cycle as a white dwarf star. If it were at the distance of Alpha Centauri, Arcturus would outshine everything bar the Moon and the Sun, and indeed the remnants of Arcturus may yet give life to future star and planetary systems. It seems this beautiful red star will live on, one way or another. Thanks for watching, and consider subscribing if you haven't already. If you would like to support the channel further, you could consider buying me a coffee, and I'll link this in the description. Thanks to those of you who have already done so. And if you have any videos or subjects you'd like to see brought to light, don't forget to let me know in the comments below, and perhaps next week your idea could show up. Take really good care of yourselves, look after your friends and family well, and I'll see you on the next one.